Hello, welcome to lesson 1-10. It's Mr. Thomaswick here with your next video lesson. We are focusing today on subtracting polynomials. Our learning target today is going to be pretty simple. It's just going to be that I can subtract polynomials. What you're going to find is that subtracting polynomials is very similar to when we were adding polynomials in the last lesson, but the only thing that's going to be different is we're going to have that little minus sign that we're going to have to figure out what to do with. We're going to do a couple examples in just a minute of the same problem. We're going to do it in two different ways, once horizontally and once vertically. Just to preview it though a little bit, the first thing we're going to have to do is take the negative sign or the subtraction sign and distribute it through the parentheses. What that really means that we're doing is we're really distributing a -1 and we're multiplying each term within the parentheses by a -1. So what might be helpful for you to do to be able to remember this step is to stick a 1 in between that negative sign and your parentheses so that you remember that you need to distribute that -1. One thing to remember, just like in the last lesson, we can only combine terms when they have the same variable and the same degree. That means that their base has to be the same, so they would both, for example, have to have an x, and their exponents would have to be the same, so their little number up top would need to be the same. If we have x squared and x squared, we can combine that. If we had x cubed and x cubed, we can combine that. What we can't do is combine things when we have the same base but different exponents. We cannot combine an x squared and an x cubed. We also can't combine two things that have the same exponent but a different base. If we have an x squared and a y squared, even though they're both squared, we can't combine them because the x and the y are different. Alright, so let's go ahead and jump into an example. We are going to simplify this expression. We have x cubed plus 3x squared plus 5x minus 4 minus the quantity 3x cubed minus 8x squared minus 5x plus 6. So here's the minus sign that we've been talking about. And this is where I was talking about that you could put the 1 into the problem. Because what we're doing is we're taking -1 and we're distributing it. So we're multiplying -1 times each one of these terms. So if I'm simplifying this horizontally, what I want to do first is I want to write down my original expression. I want to write down that first polynomial expression in the problem. Now what I want to do is I want to multiply everything in this one by -1. So anything that's going to be positive is going to become negative, and anything that was negative is going to become positive. So I take a -1 times a positive 3x, and a positive 3x cubed. I'm going to get -3x cubed. Here I have a negative times a negative, and that's going to give me a positive 8x squared. Again, I have negative times a negative, so that's also going to be a positive 5x. And now I have a negative times a positive 6, which is going to give me a -6. So what I want to do now is combine my like terms, just like I did when I was adding polynomials last time. This is basically turned now into a problem where we're adding polynomials. So what I want to do is I want to combine all my like terms. Those are the terms that have the same base and the same exponent. And Ms. Blaylock might have shown you this tip in the last video, but one thing that I like to do is I like to put shapes around my like terms, so I make sure I include everything and don't leave anything off. So I'm going to take all my x cubes and I'm going to put a box around them. Notice I also make sure to include any symbols that are in front of it so I can keep separate anything that is positive and negative. Alright, I'm going to just draw a circle around my squareds, my x squareds. I have a 3x squared and I have an 8x squared. Let's see, we'll draw a triangle around our x's. And I'm just going to underline our constants. And that tells me that anything that's in the same shape I'm going to need to combine. So if I have a positive x cubed and a negative 3x cubed, remember if there's no number in front of the variable, it's a 1. So this is really a 1 minus 3, which is going to be a -2x cubed. I have a 3x squared and I have an 8x squared. That's going to give me an 11x squared. I have a positive 5x and a positive 5x over here, so that's going to give me 10x. And I have a -4 and a -6, which is going to give me a -10. And I don't have any more like terms. I have everything simplified the best I can, so that is going to be our answer. -2x cubed plus 11x squared plus 10x minus 10. Alright, we're going to take a look at the same problem one more time. We're just going to do it in a different method, and that's going to be a vertical method. This is probably the method I prefer. Alright, when we're doing vertically, that means up and down. So like this if you're having trouble picturing that. So what I'm going to do is I'm going to first write my very first term. And that is x cubed plus 3x squared plus 5x minus 4. And now I'm going to set up like a subtraction problem, kind of like you've seen in elementary school or middle school. I'm just going to move my minus sign down here, and I'm just going to rewrite my second expression there. I have my 3x cubed, I have my 8x squared, I have my negative 5x, and I have my positive 6. Now one thing that you'll notice I'm doing is I'm lining up my like terms. I'm making sure that I have all the x cubes together. I'm making sure I have all my x squareds together. I'm making sure I have all my 5x's together. And I'm making sure I have all my constants together. Now, if I were to say not have an x squared, let's say that negative x squared was not there. This is again just a hypothetical side note, but I would line it up and just leave a space there. So if that problem did not have the 8x squared, I would write negative 3x cubed. I would skip a spot there and I would just move over the 5x there so that everything's still lined up. You always want to make sure that your like terms are lining up. But again, that was just a hypothetical. That's not part of the actual solution for this. All right, and then the last thing I'm going to do is I'm going to draw a line under here to show that I'm going to have to subtract these. Now, what I'm going to do is I have to still get rid of that subtraction sign. All right, so I'm going to distribute it through the bottom terms. So I'm really going to turn this into an addition problem because I'm just going to change that negative to a positive. But that means I have to change the sign on everything else in this particular term. All right, so like I said, we are going to change the sign. So this was a positive, so it's going to become negative. This was a negative, so it's going to become positive. This negative is going to be positive. And that positive is going to become negative. And then we just add going straight down. So I have an x cubed minus 3x squared is going to give me negative 2x cubed. Sorry, I misspoke there. It's x cubed minus 3x cubed, and that gives us the negative 2x cubed. Then we have a 3x squared and an 8x squared, and that's going to be an 11x squared. I have a 5x and a 5x. I'm going to add those together, and I'm going to get 10x. And I have a negative 4 and a negative 6, which is going to give me a negative 10. The reason I like this method, it helps me line up my like terms a little bit easier and combine things, but really whichever method you prefer, Ms. Blaylock and I are fine with. Alright, that concludes this video lesson for 1-10. Go ahead and complete the practice problems on page 18, and then pick up an application 1-10 from the Algebra Embassy. Alright, see you guys next time.